All right, we're going to start talking about inverse trig functions today. And one of the things that you might notice is in the very top corner of the paper, I have written my trig chart and my little plus part that I do for the ASTC. It also has the coordinates for the radian values that are on the axes themselves. And that's what I really need for this information. What we're going to be working with is all going to be in radians. So while my trig chart has 30, 45, and 60, I won't be using those. I'll be using pi over 6, pi over 4, and pi over 3. So let's jump right into it. We're going to talk about the basics in this video, and then in the next video, we'll do some combination problems. So first thing, we've got inverse cosine functions. Now, what does it mean? The inverse cosine of x is equal to theta. Well, that doesn't really necessarily help me. Basically, what's happening here is if you think about cosine of theta equals x, and we've been doing that stuff for a while. If I gave you cosine of pi over 3, so I would ask you cosine pi over 3, well, that's 1/2. So you're kind of used to that process. Now what we're doing is I'm going to give you the inverse cosine of something. So I'm going to give you something in this line. Either pi over 3, I'm saying pi over 3, it's root 3 over 2, root 2 over 2, or 1/2, and you're going to have to tell me what angle it is equal to. All right, so when is cosine 1/2? Well, cosine is 1/2 at pi over 3. When is cosine root 2 over 2, pi over 4? That's kind of the idea here. Now, one of the big things is cosine has this very specific domain. And the domain for cosine is from 0 to pi. So what that's going to look like is on the unit circle, we've got 0 over here, we've got pi over here. So cosine is this half of your unit circle. In the first quadrant, cosine is positive. In the second quadrant, cosine is negative. So those two quadrants combined give us every possible value for cosine. So from 0 to 2 pi is everything. All right, so let's start looking at this. I want to know the inverse cosine of 1. So I know this is 1. If I look at my cosine, my trig chart here, 1 isn't listed. So now I want to look at the ASTC chart, and I'm going to zoom in on that. And I want to remind you that every ordered pair on the unit circle is in the form cosine theta, sine theta. So what I'm looking for is where is cosine, this x value, equal to 1? And it's right here at either 0 or 2 pi. Now, 2 pi is not part of my domain, so the only possible answer is 0. So the inverse cosine of 1 is 0. All right. Number 2, inverse cosine of root 3 over 2. This is positive root 3 over 2, so it's pretty straightforward. Root 3 over 2 is right here in my trig chart. That corresponds to pi over 6 as my radian measure. So the inverse cosine of root 3 over 2 is pi over 6. So that one's done. Inverse cosine of negative 1/2. Now this one's a little bit tricky because we're dealing with a negative. So first thing I want to do is just find the inverse cosine of 1/2. So inverse cosine of 1/2, which is right here, is pi over 3. However, I need this cosine value to be negative. So I have to figure out in the second quadrant what cosine value would correspond to that. So if I picture it, and I'm going to zoom in on this, all right? So somewhere over here is an angle that is pi over 3 off of the x-axis. That's my reference angle. So how am I going to figure out what this angle is? Well, I know this side is pi, which could be rewritten as 3 pi over 3. The only reason I did that is to match my two denominators, okay? Now, this is 3 pi over 3, which would be a half of the unit circle. This is pi over 3 off of that. So I'm going to take 3 pi over 3 and subtract pi over 3, which means my value here for problem number 3, the inverse cosine of negative 1/2 is 2 pi over 3. So if your cosine value, if this argument is negative, you have to put yourself in the second quadrant. If you are positive, then you are probably somewhere in the first quadrant. The only times that might be a little bit weird is if you're on the x or y axis themselves. All right, so that is the basics of the inverse cosine. Let's go ahead and slide on down to inverse sine. Now, one other quick thing, and this is a little note here, inverse trig functions can be also written as arc sine or arc cosine. So just be aware, this cosine to the -1 or inverse cosine can also be written as arc cosine. So if you see that, it's the same thing as the inverse cosine. All right, inverse sine function. We've got the same exact setup here, right? It's the same idea in terms of how these inverse functions are going to work. The domain, however, is different. All right, domain for sine is very different than domain for cosine. So domain for sine is your first and fourth quadrants. However, because we want to keep it a continuous range of values, instead of dealing with 3 pi over 2 to 2 pi here in the fourth quadrant, we're actually going to go with the negative values here, which means we're going to have negative pi over 2 up to 0 and then up to positive pi over 2. In quadrant 1, sine is positive, and in quadrant 4, sine is negative. So again, that will get all of our possible values for sine within those two quadrants. All right, so when is sine equal to 1? All right, I'm going to go ahead and slide up to my ASTC chart so I can see where that is. All right. So remembering again that sine is my y value for all of these ordered pairs, there's one place where sine is equal to 1, and it's right here at pi over 2. So that answer here, the inverse sine of 1 is pi over 2. All right, so this is that notation you might see, arc sine of negative root 3 over 2. So this is negative, which is going to be a little bit tricky because we're going to have to deal with that in a little bit. However, I'm just going to use the root 3 over 2 part first. And so what I want to do is go up to my trig chart. Trig chart. When is sine? Here we go. So root 3 over 2 is right here, and this is pi over 3 as my reference. Now, keeping in mind that this is negative, this is the one place where sine is actually pretty nice. Because we're in the fourth quadrant here, but we're dealing with the negatives, so negative pi over 2 to 0, you actually can just say it's negative pi over 3, because that would take the angle that's up here in quadrant 1 and reflect it down here into quadrant 4. So that is absolutely okay because your domain allows for that answer. All right, last one within sine here, the inverse sine of negative root 2 over 2. Again, the negative part I'm going to temporarily ignore. I just want to check out where is the inverse sine of root 2 over 2. So trig chart, inverse sine of root 2 over 2 is right here at pi over 4. However, I need that to be in the fourth quadrant because I need it to be negative. So down here in the fourth quadrant, we're going to use negative sign values. So negative pi over 4. Again, that is the reflection for the pi over 4 that would be in the first quadrant into the fourth quadrant to get that sign value to be negative. All right, so that's the basics for the inverse trig functions for sine. We've got one more set to go, which is the inverse trig functions for tangent. Now, to make my life a little easier, I'm actually going to do a quick loop up of my trig chart. I'm going to copy this and this. Whoops, apparently I tried to copy it too fast. Let's try that again. All right, let's do a copying that. Let's go ahead and paste it down here. So this way I'm not constantly going back and forth. All right. So tangent, cosine, and sine all have the same definition for these inverse functions. So the inverse tangent of x is equal to theta, exactly when the tangent of theta is equal to x. So you keep hearing me say it, when is tangent equal to something, or when is cosine, that type of thing. For tangent's domain is similar to the sine domain, but it is not identical. I say it's similar because if you look at the actual domains, and I'll actually do this so you can see them both, the domain for sine has brackets, the domain for tangent has parentheses. Seems like a small thing, however, the domain for tangent cannot include negative pi over 2 or positive pi over 2. Those are places where tangent is undefined. Those are your two of your vertical asymptotes, so we don't include those in the domain. So visually, if it helps you, you are looking at the first and fourth quadrant. First quadrant, tangent's positive. Fourth quadrant, tangent's negative. We are going to go up to pi over 2 but not include it. We're going to go down to negative pi over 2 but not actually include it either. All right, so let's start here. Tangent, I want the inverse tangent of -1. So I'm going to go to tangent. Right here is 1. So that leads me to pi over 4. However, because this is a negative, I need to be in the fourth quadrant. So to make it negative, we're going to make it negative pi over 4. Okay, so that would be the reflection to push it into quadrant number 4. All right, arctangent, which is the same notation as inverse tangent, arctangent of 0. Now, if I go here and I look at my tangent line, I don't have 0 in the tangent line, and I don't have a coordinate here that says, oh, it's cosine, sine, then tangent. So I need to remember, all right, that tangent of theta is defined as the sine of theta over the cosine of theta. So if I want tangent to be 0, which that's what this is saying, I want my tangent to equal 0. I'm just trying to figure out when that happens. In order for this to happen, I need this fraction to equal 0, which means I need sine to equal 0. All right, so that logic again. In order for tangent to be 0, I need this fraction to be 0. The only way I'd make a fraction equal to 0 is if the numerator is equal to 0. So what I'm really looking for is when is sine equal to 0. So using that information, sine is equal to 0 here and here, but this half of my unit circle is out of my domain. So I'm just going to ignore this left side. So this right side here, sine is 0 at 0. So the arctangent of 0 is 0. All right, no, that doesn't always work out, but it's kind of nice when it does. All right, last but not least here, we've got the inverse tangent of root 2 over 2. Now, if I look at right here, I've got root 3 over 3, I've got 1, I've got root 3. Root 2 over 2 isn't an answer here. So this particular problem, you actually can't pull off of your trig chart. You can't pull it off of here either. So this is a place where you could actually throw this into your calculator. If you do it in radians, you're going to get an answer of 0.615. And if you do it in degrees, then you have an answer of 35.26 degrees. All right, so if you have any questions or concerns about that, let me know. We are going to be solving some equations where we will be working in radians, and I would expect you to work with your trig chart and your ASTC chart. We're also going to be solving some equations later on where you are going to have to be in degree mode, and we'll solve some stuff that way. So this is the basics of the inverse tangent, inverse cosine, and inverse sine. I'm going to go ahead and cut the video here. Page 2, I'll go ahead and put in a separate video. Please let me know if you have any questions or concerns. And if you do, email them, ask me in Zoom, whatever you need to do to ask some questions.